Hello students, and welcome to Dimensional Analysis number 2 notes. Today we're really going to learn the benefits of dimensional analysis. Alright, I figured if we're going to do dimensional analysis number 2, we may as well just jump right into the good stuff. So here, we are given 75 miles per hour. One thing to note, this is different than what we saw in dimensional analysis number 1. Now we have a unit over a unit. Before, we may have seen something like 75 miles or 75 hours, but we never saw a unit over a unit. Couple important things to note when you see a unit written like this, like 75 miles / hours, it is the exact same thing as 75 miles over 1 hour. Just like if I were driving my car and I said I'm going 75 miles per hour, that means that for every 1 hour I'm traveling, I'm going a distance of 75 miles. Another important thing to note with this is telling me that 75 miles is equal to 1 hour. Because again, it's an equivalence. 75 miles is equal to 1 hour. Just like I could go to the vending machine and say that $1.25 is equal to a pack of Pop-Tarts. It's an equivalence. And then we need to get to a goal of meters per second. So what happens now is we actually need two separate paths. We need a path for the top and we need a path for the bottom. I can't convert miles into seconds because miles are a unit of distance. Seconds are a unit of time. They can't be compared. So I need to go miles into meters and hours into seconds. So what we're going to do is let's go through and get a path for the top first. So for the top, I'm going to convert miles, and we're going to look at our conversion sheet. And down here you can actually see there's going to be a couple different paths you could take. To get from miles into meters, we could convert miles into yards, and then yards into meters, or we can convert miles into kilometers, and then kilometers into meters. You'll get about the same answer regardless. It might be a little bit different because conversions aren't perfect, but for the sake of this, I am just going to go from miles to yards, and then yards into meters. Then for the bottom, we need a separate path, and that path is going to be hours to minutes into seconds. And then just like we did in the first one, now the process is actually very similar. We're going to need 1, 2, 3, and 4 conversions. So I'm going to go ahead and write those down. So my first conversion is from miles into yards, and that is that 1 mile is equal to 1,760 yards. Second conversion is from yards into meters, and that is 1.09 yards is equal to 1 meter. Third conversion is hours into minutes. I know 1 hour is equal to 60 minutes. And then the fourth conversion is minutes into seconds. And I know that there is 60 seconds equal to 1 minute. And we're going to start this one similar to what we did in Dimensional Analysis Part 1. First thing I'm going to do is I'm actually going to write in 75 miles. But now what happens is we actually have something on bottom. Remember in the first set, this area below our given, or below what we wanted to convert, was always empty. Now we have something to put there, and that is going to be 75 miles per 1 hour. And now what we can do is we can add on our sections of railroad tracks just like we did before. So we know we're going to need 1, 2, 3, 4 sections of track. So I can go ahead and draw those out. And I'll probably be writing my answer down below here later. Alright, so let's go ahead and get started with some dimensional analysis fun. Here we have 75 miles on top, so if I have miles on top, I need to look at my first conversion. Again, you don't have to draw these numbers out. I'm just doing it so you guys can see that, okay, conversion 1 is going to go here, conversion 2 here, conversion 3, and conversion 4. So if we have miles on top, miles have to go on bottom, and therefore I'm going to write 1 mile per 1,760 yards. Miles are going to cancel with miles, and now if we were to stop right now, we would be in terms of yards per hour, because we have yards on top, hours on bottom. That's not what we want. We want to get to meters per second. So we continue on, and now we have yards on top, so we need to get yards on bottom. And again, we are using our second conversion now. So I'm going to write 1.09 yards on bottom is equal to 1 meter. Yards and yards cancel out. And if I were to stop now, I would figure out how many meters I'm going in 1 hour, because those are the only 2 units I have left. But again, I need meters per second. And now is where things change up just a tiny bit. It's the same concept, but it's a little different. So here, the reason that we had miles on bottom is so it would cancel out miles on top. The reason we put yards on bottom is so it would cancel out yards on top. But notice here, we have hours on bottom already. And we need to get rid of hours. We don't want hours in our final answer. So now if we have hours on bottom that we need to get rid of, we're actually going to have to put hours on top so that way they cancel out. So I'm going to look at my third conversion, and I see that the third conversion is 1 hour per 60 minutes. So that's how you know what unit goes where. Is if you need it to cancel out, if it's on bottom, you have to put it on top. So those hours are going to cancel out. Again, please note, the 1 is not canceled out, just the hours are. And we continue on, and now we have minutes on bottom, so we're going to have to put minutes on top. And we have 1 minute per 60 seconds. Minutes cancel out with minutes, and now you'll notice our final units, we have meters on top, seconds on bottom, and life is good. And now what you'll need to do is multiply everything on top, so 75 times 1,760 times 1 times 1, then divide it by, and I'm actually going to write this out, so make sure you put it into your calculator correctly, so 75 times 1,760, and then times 1 times 1 times 1, which doesn't affect anything, then divided by, again, 1 times 1, which doesn't matter, then 1.09 times 60 times 60. And when you plug this into your calculator, you get an answer of 33.64. And then we have to bring in our units of meters per second. One thing I want you to be very, very careful with, and what I want everybody to do, is make sure you practice plugging this into a calculator. It's very common that students will put these into their calculator wrong, because you have to be careful. When you plug these in, you can't type in 75 times 176 divided by 1.09, and then if you press times 60, it's actually going to think the times 60 is up top, not down below. So if you're going to type it in like this, you have to use parentheses around these numbers. So please make sure you're practicing putting that into your calculator and that you are getting this answer of 33.64. If you're not, please see your instructor for help. Alright, I know we had so much fun on the last slide. Let's just do another problem. We'll go a little bit quicker this time because I don't need to explain as much. So again, here we have our given up top, which is 0.45 kilometers per minute, and we want to convert that into, again, meters per second. So let's go through and figure out our path. In this case, if we take a look at our conversion sheet, and by conversion sheet I mean number line, I'm going to have us use this again. We need to figure out a conversion from kilometers into meters. And again, since we have this prefix kilo here, but we have the same units in meters, we can convert it. So our path then is going to go from kilometers into meters. That's nice because it's just a one-step conversion, but we do need to figure out what that conversion is. So we're going to use our number line. Down here, we take a look and we have our base is going to be regular meters, and then we have kilometers over here. So again, we need to think to ourselves, well, which one is smaller? In this case, whatever is furthest left is smaller, so it's going to be regular meters. So we're going to have 1 meter is equal to so many kilometers, and we need to figure out, well, how many meters are in a kilometer? In this case, we are going to move over 1, 2, 3 spots. So therefore, we're going to add 1, 2, 3 zeros. And so we have our first conversion here. And that first conversion is that 1,000 meters equals 1 kilometer. But keep in mind, we also need our path for the bottom. We need a path from minutes into seconds. So in this case, we're going to write out our second path, and that is from minutes directly into seconds, and that's going to be a second conversion. So our second conversion, 1 minute, is equal to 60 seconds. And you can probably already see this problem is much, much shorter than the previous one. I don't know, I just wanted to start us off with the challenging problem, so that's what we did on the last slide. Realistically, that slide was probably about as difficult of a problem as you would really come across. So anyway, let's go on and continue solving this one. So we're going to write out what's given to us, which in this case is going to be 0.45 kilometers. And again, that is over 1 minute. And then when we finish building our tracks, we're going to need 2 conversions. We have kilometers on top, so we need to put kilometers on the bottom. 1 kilometer per 1,000 meters. Kilometers are going to cancel out with kilometers. If we were to stop right now, we would be in terms of meters per minute. That's not what we want. We want meters per second. So the top is now good. That's complete. We got to meters. The bottom, however, is incomplete. And again, remember, we're at minutes on bottom now, and we need minutes to cancel out. So if minutes are on bottom, in order to get them cancel out, we have to put minutes on top. So 1 minute per 60 seconds. Minutes can cancel out, and hey, look at that. We're already done. And we have our meters on top, seconds on bottom, so we're good. So now all we're going to do is take 0.45 times 1,000 times 1 divided by 1 times 60. And when you plug that into your calculator, you should get an answer of 7.5 meters per second. So now you know that if you're traveling 0.45 kilometers per minute, that is the exact same as traveling 7.5 meters per second. Alright, just like we've done in the previous videos, I would like you to now pause this video and try and solve this one on your own. And just remember, I believe in you. And I will put the answer up here in just a few seconds. Alright, and the answer to this problem is 1,322.75, and then we have units of pounds per kiloliter. So if you got that correct, you are welcome to move on. However, if you did not, please follow along to the rest of this video so you get some help on how to solve this problem. If you still have questions, please make sure to ask your instructor. Alright, what we need to do now is figure out our paths. So path for the top, we need to get from grams into pounds. So figure out our path. If we look down at our conversion sheet, I don't have a conversion straight from grams into pounds, but we can go grams to ounces and then ounces to pounds. So we're going to convert grams to ounces, and then ounces into pounds. Then we need a path for our bottom. And for the bottom, since these are both a base of liters, deciliter to kiloliter, we know that we can do it in one step. We're just going to have to use our conversion sheet, or our number line. So our path is going to be deciliters to kiloliters. And please remember the difference between lowercase and uppercase d. Lowercase d is deci. If this was a capitalized D or an uppercase D, it would be referring to deca. So we're going to use that number line to actually solve for this. And in this case, deca is going to be our smaller unit. So I'm going to write a 1, leave some space, and write deciliter is equal to 1 kiloliter. And now we're just going to count our number of spots that we move over in order to figure out how many zeros we need. So we need to move over 1, 2, 3, 4 spots, which means we need to add 1, 2, 3, 4 zeros. So now we know that there are 10,000 deciliters in 1 kiloliter. Alright, in this case we're going to need 1, 2, 3 different conversions to solve for this. Our first conversion is 28.35 grams is equal to 1 ounce. Second conversion is that 16 ounces is equal to 1 pound. And then our third conversion is going to be the 10,000 deciliters being equal to 1 kiloliter. So now we take what's our given or what we want to convert, which in this case is that 60 grams per deciliter. So we're going to write our 60 grams per 1 deciliter on bottom, and then we are going to draw out our 3 separate pieces of railroad tracks. And now that I have grams on top here, we know that we need to write grams on bottom, so we're going to have 28.35 grams on bottom, and that is equal to 1 ounce. So now grams on top are going to cancel out grams on bottom. Now we have ounces on top, so we need to write our 16 ounces on bottom, so that way those can cancel out, and that is per 1 pound. So ounces on top cancel out ounces on bottom. And then the last thing that we need to do, since we have deciliters on bottom now, remember that they need to go up top, so that is 10,000 deciliters was equal to 1 kiloliter. So deciliters on bottom can cancel out deciliters on top. And now we just need to multiply. So multiply everything on top, and then it'll all be divided by everything on bottom. And when you plug this into your calculator, you will get 600,000 on top divided by 453.6 on bottom. And when you plug those into your calculator, that gives you the answer that we mentioned earlier of 1,322.75 pounds per kiloliter. Again, I hope this made sense, but if you still have any troubles, please make sure to ask your instructor for additional help.